All right, welcome to week 3 of Intro to Programming for Business Majors. This is a series of video lectures I'm putting together as additional material for my class. Okay, we're going to continue on a discussion of Chapter 2, which is kind of, Intro to Java and the syntax. In this chapter, we had the main topics were the parts of the Java program. We did the print and the print line methods and the Java API. We discussed variables and literals, primitive data types, arithmetic operators, combined assignment operators, creating named constants with final. Now we're going to go over the string class, scope, comments, programming style using the scanner class for input and dialog boxes. Okay, Java has no primitive data type that holds a series of characters. The only primitive they have is char, which is a single character. The string class from the Java standard library is used for this purpose. In order to be useful, the variable must be created referencing a string object. So you just create a reference right there, string, and then that's the name of your variable. So number would be the actual name of the variable. Notice the S in the string is in uppercase. By convention, class names should always begin with an uppercase character. And again, convention is not rules. There's a difference, okay? You can create a class with lowercase letters. It doesn't matter. You cannot declare a variable an integer, then puts a string into it. That's a rule. So the difference, I would say follow convention. Most people do, but just keep in mind that convention doesn't mean you can't do it. So primitive versus reference variable. Primitive variables actually contain the value that they have been assigned. So number equals 25. The value 25 is stored in memory location associated with that variable number. The objects are not stored in variables, however. Objects are referenced by variables. When a variable references an object, it contains the memory address, the object's location. Then it said that the variable references the object. So string city.name, or not name, city name equals Charleston. Okay. So the city name is the address to the object Charleston, the object that contains the character string Charleston. Okay. A variable can be assigned a string literal, meaning it's right there in the quotes. Strings are not the only objects that can be created in this way. A variable can be created using a new keyword. So what this is this is kind of the way all other objects are instantiated when you create one. So if you created your own class and you wanted to develop an object from it, you'd have to do this, say with the new objects, and then tell what it is, okay? So a little different way, we'll look into that in a future class. So in here what we're doing, we have this demo package here, and we've set two string names here. Okay, so we've got string greeting equals new string original morning, and string name new string original Herman, and prints out print line greeting plus name. So if we run this, you get the result, good morning Herman, which you start with good morning and then Herman, and then all we're doing here in the print line is we're concatenating the two names, because it's not an addition, it's concatenation, because we're using strings. Remember, if either side of the plus is a string, you are concatenating. If these two happen to be integers, you would have just been adding the two numbers up there. Okay, so you don't have to do it this way. Like a good example here would be, I can do the same thing just like this. I can say Herman here in quotes, and this will give me the exact same results once I get rid of that extra character. And if I run this, it'll work too. So because that's the way string works, but any other type of variable you're going to do, any type of object you want to instantiate, and again, there's the answer, it's the exact same answer. you would need to use this new method, and we'll get into it later. Okay, let's go ahead and back to the slide deck now. Okay. Since string is a class, objects that are instances of it have methods. One of these methods is the length method. So in this statement here, what we've got here, you need to imagine that we've created a variable is called value, okay? And then because we derive this variable as a string, it's part of a class. All the methods that come with that class now can be used on that variable. So now I'm using variable.length, and that will tell me the length of the variable. And here let's pop over again into Java and take a look at this. So what we've got here is we've got two variables. One, string, and that carries the name Herman. So the name of the variable is name. And then we have an integer, string size, okay? So the integer, remember, that's part of a primitive. So it's built into Java, where the string is not a primitive. So the string is a class, which a class comes with methods when you make an object out of it. Okay, so what we're seeing here is the value I want to assign string size is the length of my name, my variable. So what do we mean? When you see a variable or any value that has a dot after it, what you're showing is this is my object. This is a method of the object. And the method comes from the class because this object is of class string. You see the same thing down here. I have system. System's a class. Out and print line, these are methods. With the string, with system is so big, out's like a subclass. That's the next level because you have to characterize. There's so many things in there. But all this does is this will return the number of characters in the string if I run this. So let's go ahead and run this file again. And when you go ahead and look at the results here, you get Herman has 6 characters. And so the main thing to think about is when you see the period after something, after a name, you know you're probably looking at an object that's part of a class. Okay, let's pop back over into our deck here. And so that's how the length value works. And that's just a method from strings. Okay, string contains many methods that help with manipulation of string objects. String objects are immutable, meaning that they cannot be changed. Many of the methods of the string object create new versions of the object. So go ahead, let's pop over and take a look at what the string methods are, what we've got here. And let me blow this up so we can actually read it. So we're putting in a string. Java is great fun. String upper. Now notice we're just taking this right here. So notice this. So we're using this object we've already created and we're putting things to it. So now we're going to make a new object and it's going to be to uppercase to lowercase. Character at index is 5. It's going to pick the 5th character of Java is fun. And then this is going to give you the length. So if I run this, run anyway, and we go ahead and look at the results. So you see what it does. It made one normal, then we had uppercase, lowercase, then this picked that character at its position 5. So this is Java. I mean, this is the main idea we're trying to get here is that you're looking at is these are all methods of the string. These all come from string. So all these methods are built into the string. So back over to our deck here. Okay, so these are just different methods. And like I said, some of these methods are so many, you'd be hard to find, okay, to just describe them all. Okay, scope. Now let's get into it. Scope refers to the part of the program that has access to variables contents. Variables declared inside a method, like the main method, are called local variables. Local variable scope begins at the declaration of the variable and ends at the end of the method from which it's declared. Okay. And we see scope Java. This program contains an intentional error. So that's what one we've been looking at when we have the problems downloading. So we can look at that in an example here. Let's go ahead and pop over into that. Okay, all right, so here we have a program that was written intentionally to have an error. You'll notice there's a couple of them, and this one's got an error in it too. You can tell just by the red dots in there, the red exclamation points. So, and we can see the errors are sitting here. And if you wave over this, it'll kind of give you a hint. Can't find the symbol, variable name. Okay, so here's the problem. The problem is this. I'm trying to print out a value before it's been declared. The variable can't be declared unless you've got it there. So, and the other side to think about is, and we're not doing it here because just it's not in this example. If we had more than one method, this local variable does not exist outside of this method. Now that I've done that, my error's gone away and this should run. So now I run the file and there's, say, I've got other one. That message keeps coming up because there's R values that have errors in this intentionally, clearly. You know, they put it in the doc in the programs. But there you go. That shut out the run 100. So the big issue, like I say, to keep that whole point of that was that in the scope, you got to think about, you got to make sure you declare your variables locally before you have any intention of using it. You know, so you can't use a variable until you've declared it. Okay, I'm going to end this video and we'll pick up next for the next part of the video. Go ahead.